So, when you arrive in Dr. Sauer's class, you're the 7th person at 2:15, another person joins at 2:16, and 2 more people join at 2:17. Assuming this pattern continues, write an explicit arithmetic formula for this situation to find how many people will walk in n minutes after 2:15 and determine what time the classroom violates the fire code, where the fire code says that 206 people can't be in the classroom. Let me get up the answers here. Oh, that's not right. Okay, that's much better. So the formula for an explicit rule is this, and if we substitute in all our terms, because it's only going up one each term, it's basically the term number is equal to the term value. And then this is the formula for an arithmetic series to figure out how many kids, or how many minutes it's going to take for a certain number of kids to join so that we're going to violate the fire code. And we're going to set this equal to 595 because if we take away the 7 kids that were already in the classroom, now we just have to worry about how many kids we're going to add. So now if we solve for n to figure out how many minutes it's going to take, we find that it's going to be 34 because we can't be negative 35 minutes. So at 2:49, there's going to have exactly 602 kids. So at 2:50, we're going to start to have to be evacuated because we might die. So someone in line says that this identity says how many kids. It's like a shortcut for how many kids will join at n minutes. So that's represented by this summation. So we figure out that it works for n equals 1, and that if so we set up so that if this is it for n, then we can set up something for the summation of k to the n plus 1 term. So we just substitute n plus 1 in for all the n's in this, which would give us the summation, if this is true, of the next term. And since the summation of k to the n is equal to this, then we can say that the summation of k to the n plus 1 is equal to this plus n plus 1 to have that extra term in. So now using substitution, we can say that the summation of k to the n plus 1 term is equal to the summation of k to the n term plus that extra term of n plus 1. So again, using substitution, we can say that assuming that this is true, we can substitute this guy in for this and say that the summation of k to the n plus 1 term is equal to n squared plus n over 2 plus n plus 1. So now we have two things that should be equal to the summation of k to the n plus 1 term, these two. So if we set them equal and they equal each other, that means that it's correct and the summation or the theory should work. They do end up, once you simplify them, to be correct, so this should work. So after standing in line a while, you decide to check your bank account from Comet Savings and Loans. Originally, you had 1 cent in the bank account, and when you joined the line, and the interest rate was 2.5 and compounded monthly, the bank notice says you have $10,000 in your account. How long have you been in line? So this is the formula for compounded interest. Let's substitute in our values, and then solve for t. So it goes all right until you get to this part where you have to take the log base 481 over 480 of 1 million. So because logs and exponents are inverses, this log 481 over 480 cancels with this, and then we're left with this. So then we just divide by 12t, or divide by 12 to get t alone, and you've been standing in line for 553 years. So that should mean that you've gotten through about like 2 or 3 papers. So you'll be done in no time. So you want to graph my first initial, and I appreciate it a lot because you really think I'm cool. So we're going to use these 2 parent functions, this parabola and absolute value. So to create the squiggles on the ends of the W, we're going to use the parabolas. We're just going to keep them fairly simple. We're going to have one that has a vertex at -3, and the other one has a vertex at +3. So we've just shifted them left and right. We're not going to do anything else with them, but we're just going to limit them to -8 and 8 on their most extreme ends, and to -3 but not inclusive, and to 3 and not inclusive either, because I want the other function to take up these 2 spots, this -3 and 3 part. To create the next part, I'm going to use an absolute value function. So it's going to need to be opening downward. It's going to need to be somewhere in this range, and it's going to need to go through -3 and 3. So what I'm going to do is I'm going to take the absolute value function and put a negative on the front, so it flips it downward, opens down. I'm going to add 9 to it, so it moves up into this area, and then I'm going to stretch it by 3, so it goes through these 2 points. And then there you have your W. If you limit it to -3 and 3 inclusive, because the other equations did not include these 2 points. So someone else says that they've made a better W because, you know, it is. I mean, it is. It's just one nice line. Here it is. So this is their W. It's much better than yours. Domain, -infinity to infinity. It just stretches on forever, much like my legacy will. The range is so from 0 inclusive, because it does hit these points tangentially. I think that's a word. Just hits them and then goes right up. These are only a single point. The y-intercept is 196. You could look at that on the graph, but you can also see that this is the only the constant in the problem, or the formula, is 196. It's the one without the x. So that's how you know what your y-intercept is going to be. Because when all of these are 0, that's the only one that's going to matter. Yeah, x-intercepts are 2 and 7. These hit tangentially, so they hit just barely and then leave, and then hit just barely and leave. So that means that it's the vertex of these parabolas, which means that if we factored this, it would look like x minus 2 squared times x minus 7 squared, because they just hit once and then they're on that vertex of the parabola. The function's positive from -infinity to 2. All this positive, and then it just skips 2 because it's a 0, and then it continues being positive from not quite 2 all the way to not quite 7. This is all positive, and then it stops being positive here, and then from not inclusive 7 to infinity, that's all positive. Negative, never negative. Its maximum is 4.5. It's here, right? But this point, 4.5 and 39.063. Its minimums are its roots down here at 2 and 7. At y value of 0. It's increasing from 2 to 4.5, both non-inclusive because those are the turnaround points. And then all the way it goes until 7, and then all the way up to infinity. And then it's decreasing from -infinity to 2, and then it starts to increase, and then it goes back down from 4.5 to 7, and then it increases from there. So its end behavior as x approaches -infinity, f of x approaches infinity, and as x approaches infinity, f of x also approaches infinity, and we don't have any discontinuities or asymptotos in this formula.